Today we had our introduction to limits. So we got a new notation, or we explored a new notation. So if we look at this writing in blue, we're going to say we're taking the limit as x approaches -5 from the right-hand side of f of x. So what that means is we're going to look at our graph. We're going to approach 5, the input 5, from the right side and see what happens to our output. So in class what we did is we plugged in numbers that were really close to 5, like -4.999, and we can just get as close as we want. We can say -4.9999999. And as we get closer and closer to -5, we're going to see what happens to our output. So at our graph, as we approach -5, what happens to our output? Well, it's going to infinity. So we write equals infinity. And that tells us that as we approach -5 from the right, our output is unbounded. It's just going to keep getting bigger and bigger and bigger. So now, looking from the left-hand side, well, we go to the left of the vertical asymptote, and we see, well, as x approaches -5 from the left, so algebraically what we would do is we would plug in, like, -5.00000001, something really close to -5 from the left-hand side. And as we do that, what's happening to our output? Well, it's going to -infinity, so we say equals -infinity. Okay, so then in class we talked about the limit as x approaches -5 from both sides. So if we write the limit as x approaches -5, we're going to say that limit does not exist because from the left side it approaches -infinity, from the right side it approaches positive infinity. We're approaching different things, so that limit does not exist. But if we look at the hole in this function, which by the way, the function is down here, so if we look at this, we see we have an x minus 3 factor on top and x minus 3 factor on bottom. So that means that we must have a hole at x equals 3, which shows up on the graph here. So if we take a limit, we can't plug in 3 to this function, because if we do, we get 0 over 0. But what we can do is plug in numbers really close to 3, or we can use our algebraic method of just canceling the x minus 3 factors and just plugging 3 into the remaining factors. If we do that, we're going to get a result of -7. So really quick, what we're going to do is we're going to approach 3 from the right, and as we approach 3 from the right, what are we hitting? We're hitting -7. As we approach 3 from the left, what are we hitting? We're hitting -7. I almost traced the line there. So as we approach from both sides, we're approaching -7. So both of these are equal to -7. So that means that the limit as x approaches 3 from both sides, so I don't specify positive or negative because that means I'm going to come from both sides, that's going to equal to -7. Okay. So limits, typically, we can take a limit at any points on this function. We can say what happens as we approach any single input, but typically we're only looking at limits when there's something interesting happening. So for example, a vertical asymptote, or a hole, or maybe some type of piecewise break, which is something we'll look at later in the unit. So all we're saying, though, really is what happens to the output as we get really, really, really close to an input. We're going to try to describe the behavior of the graph as we get close to an input.